that brings us to the next part, problem with alpha, and related to that merge maps and derived normal Z maps. So first of all, the problem with alpha. This texture has an alpha channel inside, and that's a very, very bad idea. So if you look in Photoshop, if a texture has an alpha channel in it, it will instantly double the size of that texture. So you have to be really careful with that. There are, for example, programs, I believe ZBrush or Mudbox, when you render TGAs in those programs and you save them, there's a chance that, for example, it automatically embeds a black alpha channel. If you then import that TGA into Unreal, it will take that black alpha channel and that will instantly double the size of the texture. So that's a very, very bad idea. So if you don't need alpha, make sure you really do not have alpha in the texture. Or if you do have it in a texture, make sure that when you import it, you select the box, import no compression. Compression no alpha. Enable that to make sure you don't import the alpha channel. Because what happens when you have an alpha channel is the following. Here we have our incorrect character texture with a white background, but this also has an alpha in it. And if you hover over a texture, it tells you the size. You can see this is 4 megabytes. If I would have imported the correct one, which is just the body, so this is the correct one. It has a black background and there's no alpha in it. Well, this texture is the same resolution, 2048 for both. This texture is 2.67 megabytes, this one is 4 megabytes. Having an alpha in a texture will double or almost double the size instantly. And that's because the RGB channels of a texture, those are compressed. So the RGB, the red, green and blue channels, they are compressed when it's converted to DDS. However, the alpha channel you can see here, this is not compressed. This is nearly uncompressed in Unreal. And it's usually a big waste of memory because you don't need this kind of texture uncompressed. It's just a bunch of black and white pixels. So this is a massive waste. So what you tend to do is you tend to avoid having any alpha whatsoever in any texture anywhere, unless you really, really need to have an alpha. And the only moment when you really need to have an alpha is when you really do need a high quality uncompressed alpha for what you're dealing with. So for example, for a smoke texture, yes, you probably want to have this in alpha. Because the difference is quite obvious. I can add it in my test material here. So this texture has both an alpha, a cloud in the alpha, and it has the exact same image in RGB. Okay, so if I use the alpha as I do now, I've used the alpha channel to opacity, and emissive is just a flat color. You can't really see any form of compression. It's pretty good. However, if I were to now use, for example, the red channel, besides being darker, or I can just use RGB maybe, you have a bigger chance of start seeing these kind of JPEG-like compression blocks. So it reduces the quality. So in general, my rule is if you need high quality alpha, if you need high quality grayscale images, you have to use the real alpha, you use real alpha. But for everything else that's not that quality dependent, for example, say a texture like this, which is a mask map, this you can easily compress quite hard. And this doesn't have to be an alpha. So that's my rule. And we'll do the same thing in the real character later on. I believe not a single texture in here actually was real alpha. So what do we use instead then? Well, we use something called merge maps. Merge maps are like this. This is also what we used in the first video. They are these funny colored things, and they actually contain a different image per channel. So the red channel of this contains these clouds, the green this, and blue that. And you can see the electricity here as well, it's the same effect. This is red, this this is green, and blue is in this case empty. We do the same with the character. Here we have a combined merge map, and this contains the various mask maps of the character. So here we have a big eye. This is the mask for the body, small part of armor on the hands there. And here's a mask for the rest of the metal on the body. And these are combined in one image that looks like this. So what you tend to do is you would go to Photoshop, and rather than having this kind of mask map, here we have a second mask map, and then we have the mask that for the eye. Rather than having all of this, you should be taking that in. I'm going to make a new RGB image, and I place the eye in red, then I place that one in green, and this one in, sorry, wrong channel, and this one in blue. And the result is now this. Since this is a single RGB image with no alpha, it'll be smaller. I can give you a very clear example of this. For example, if we take the fence, so here we have the fence texture. This has an alpha. We've imported this into Unreal, and this is currently 1.33 megabytes big. It's a 1024 1024 texture. Well, if I would have taken this alpha out and placed this in a separate image, in say the red channel, and in say the green channel, I would be adding something else. Say in the green channel, but for example, we add in the cloud. I'm going to scale it up, it's not very good, but just for the sake of example, how you can combine different things. And in the blue channel, say we need a bunch of lines to mask something out. So let's say we make a bunch of lines in here. In the blue channel we have this. Now we have 3 different grayscale images in here combined in single RGB, which is then saved as a normal 24-bit TGA. Plus I'm gonna resave the fence for a moment without alpha. Then the original fence was 1.33 megabytes. Well, this fence without alpha is only 683 kilobytes, and the merge map is also 683 kilobytes. However, since this merge map is reusable, it combines 3 images at once. This is more efficient. So I would now be able to use this fence and then use a merge map, that one for alpha. And then it looks like this. And then the green and the blue one we reuse later on for other purposes. This saves a lot of memory to begin with. Another thing you can do is you can abuse the normal map to store other information in it. When you have a very, very basic material like this, I quickly connected to specular as well, so it gives a very slight specular on it. When you have this, you can actually use the red and the green normal map channel to generate the blue one. If you tell the engine what red and green is, it can calculate the third one by itself. In other words, the blue one can be generated, but can be figured out by Unreal. You don't have to tell the engine what blue is. You only have to input red and green for it to figure it out. There is in fact this thing here called a derive normal z. If you add that in here, it says in x and y in red and green. Then the output of this is identical. This still looks the same as this, see? However, this isn't using blue anymore. And that's the big thing. That would allow us to do this. You can now go to Photoshop, you can now bring in the normal map texture you're using, that, and you can now use the blue channel here. The red and green it needs, but you can now use the blue channel to do something else with. So for example, you could say, I want to have the fence texture in there. It's a very bad example, it doesn't really make sense, but it illustrates the point that you can do whatever you want with blue. Now your normal map looks like that. You have red, green, and blue is something entirely different. There's one slight issue with doing this is that when the moment you set it to normal map, because sRGB is off and because the unpacking is different, it's going to slightly change the color of what you import. So your grayscale image that you've added to the blue channel is going to look slightly different than it should be looking, which again we'll get back to when we make the character. But otherwise this approach works really well. So here we have our modified normal map. I'm going to use that one instead here. And I'm going to preview the derived normal Z. And you can see it still looks identical. Even while this one now looks like that. But you could now use this one, the blue channel, and for example put it in diffuse. See? Or you could say, okay, of course that doesn't look like anything, but you could now make a second material with your fence and then set up the fence like this. That's diffuse, blue channel there is opacity mask, and the material is set to masked. So now you also have your fence back, except you're actually using the character's normal map. That's also something we'll apply later on to the character. So later on I will give you the practical example of how you actually implement this. But this is another thing you can do to start saving memory. Now if you combine all these kind of steps together, you can save a huge chunk of memory on a game. You can easily halve the game's footprint, memory footprint. Related to that is the following. Go back to Photoshop for a moment. You don't even need full resolution masks. So for example this one, or even better the other one is more obvious. This is a mask that we have for the armor. So this masks out all the bits of armor on the diffuse. So this is the texture it belongs to, and you can see that this identifies everything that's metal basically on here, which is something that we will require later on. Well, you don't need this to be a 2048. This is currently a 2048 texture. You don't need this to be the same resolution as the 2048 diffuse. You can easily make this several times smaller. You can easily make this 512 for example, and it would still look almost exactly the same in the engine. You can in fact probably make it 256. And by making this 256, it's still gonna do its job perfectly fine in the engine. Except rather than being 2.67 megabytes, it is only going to be 43 kilobytes. And it will again still do its job perfectly fine. This goes in particular for specular. If you have a specular texture, you can easily make the specular smaller than it really should be. So here's the armor specular. Well, this is 2048 as well. Why not have the specular at 1024 instead? And that makes it a little bit more blurry, but then you can always multiply that with a diffuse to get back some of the original details. In fact, you can also use a diffuse to simply generate the majority of specular entirely. Here we have a very basic material setup with a diffuse, a specular at original resolution, so the same resolution as the diffuse, and a standard normal map, which currently looks like this. However, if you use the 1024 specular, the difference really isn't all that big. First of all, I think you barely see the difference even. It doesn't even do much. This it's very hard to see, I think, if you wouldn't know it. And even if you're not entirely satisfied with it, you can always multiply this one together with the diffuse one now to get back some of the original detail. You could always do this now. Of course, the color is going to be slightly different, but you could account for the difference in color by adding a couple of multipliers or desaturation in between. But by multiplying a low resolution image with a higher resolution image, you basically bring back some of the details of the high resolution. So you don't have to make specularity the same resolution as the diffuse. You can get away with a lower resolution and then multiply them together, for example, like this. In fact, you can just get away, not always, not for this texture in particular, but for a lot of different textures, tiling environment textures in particular, you can get away with just generating them entirely. For example, if let's say we use the fence here, let's say you want the fence to have some specularity on it, well, you can get away with just generating that. It's also something I briefly covered in the first video. But if you multiply a texture with itself, you basically increase the contrast, and then we use this to increase the brightness. Well, I now also have specularity. In fact, if you look at the majority of textures in the ball, all the wood of the environment, all the stone of the environment, there's not a single specularity image anywhere in the game. All of the specularity in the ball, except for the characters, the vehicles, and the weapons, are generated like this. That's all we did, and that works fine for simple, neutral tiling textures. Of course, if you start dealing with characters and all that, you need more. But you shouldn't waste so much more. You shouldn't waste having more specularity maps when you're not really going to notice it, I think. And if you do really want specularity, I would go for halving it in size. That also goes for emissive. It's the same situation here. First of all, this is already smaller in size. So this eye belongs to the body. You can see the eye here. This is the 2048 texture. And here's the eye image, the emissive eye texture. This is first of all already only 1024. Would have been far worse if this was 2048, but it's still not good enough. We now have a 1024 big texture, which is 95% totally black and wasted space. However, this thing still takes 683 kilobytes. So this is a big waste of space and memory. There's a couple of ways we can improve this. First of all, it doesn't even really need color. Let me quickly set up the material this would be meant for, as it would be meant to be used. So you would have the diffuse texture, and then you would have this one on top. It's meant like this, so the eye glows in the dark. So this is the mask map for the eye. First of all, you don't need color on this. This could have been grayscale. I will desaturate it in here, but it should have been desaturated in Photoshop, but just for the sake of the example, adding this in between desaturates it, and then you could have simply colored it with a constant 3 vector instead. Now it's not exactly the same color, but you could just tweak this until you have the same color. In fact, rather than doing that, you could have also simply multiplied that together with the diffuse. And then you would have this. Of course, it's got a little bit darker here, so then you can always choose to multiply it again with just a color. But now I have pretty much the same result as if I would have directly connected it. And this would also allow me to use a far lower resolution emissive mask, because it's, again, for the same reason, it's being multiplied with the diffuse. It will take over the detail, parts of the detail from the diffuse. And then to take this another step further, it still has a lot of wasted space left and right of the eye. There's a way that we can work around this, and that's called, there's a function here that does exactly that. It's called an emissive submap. It's called texture cropping, and it's a function. If you drag that in, you will get this. Now I actually made my own one that's an improvement on this, because this one didn't seem to work anymore, or something was wrong with it, so I made my own one. But this is the default one, and what it does is it allows you to make a texture that's smaller than the original, than what you're trying to project it on, and then only project part of the texture on it that then stretches out. I can show you exactly how this would go in Photoshop. Here we have the eye texture in Photoshop. On UDN, this is the URL. There's a plugin that you can get. You also have to install Adobe Configurator. This plugin, if you install that to Photoshop, will give you this little tool, which is this one here. This tool allows you to crop an emissive to a small part of the original size, and then those numbers can be brought into Unreal, and Unreal will project this small little texture as if it's this big. Therefore, you avoid having to save all of this space into the texture. So I'm going to use that here now. I'm going to say I want to have just this in a texture. Or in fact, even better would be if I would set a fixed size. So I'm going to save it as a 128 by 128, which is that. And then I press crop emissive. Then it automatically asks you if you want to save it. Be careful here, this automatically makes an alpha. That's exactly what I meant earlier. You should not have alphas in the texture if you don't really need it. So I'm going to save as 24-bit and get rid of the alpha. Once it's saved, it will tell me this. And these are the numbers we have to bring into Unreal now. So I'll now go to Unreal, import the texture I just made, which is only 128 by 128. You can see this is 11 kilobyte, the original is 683 kilobyte. Now we can also make this black and white. So only use the red channel on of it and reuse green and blue for something else, and then it would have been even smaller. But this is already a major reduction. So I'll bring that one in over there. And then you will use this to distort, to offset the position of this pretty much. Now, like I said, I made my own, so I'm going to switch this one out for my own version. In the finished one, there is a fixed cropping function. I'm going to use that one instead. And those functions you can simply drag into the material editor like that. This one does the same thing, it just seems to work better. Create two constant 2 vectors. You can also find them in here. This was number 2 on the keyboard. Input them both on the right side of the function, and then put the two numbers that Photoshop told you in here. So that was 0. Take a screenshot of that instead. That was 0.731 and 0.146. And then the lower right corner is 0.856 and 0.271. I actually switched them around. That was the lower right and the other one was the lower left, upper left. Then that goes into UV, goes into the UVs of the texture, and area is multiplied with the texture. Then we have to make sure we have the right texture in there, of course. There we go. And as you can see, this also displays the texture. So now I still have a glowing eye. Now we're previewing just this. This is identical to the original big texture. this one is identical to this. So this is cropping in action. And again, this made the size, it brought the size down from 683 kilobytes to just 11 kilobytes. You can also use this for other things, not just for emissive, for whatever you want. If you only want to do something on a small part of your texture, use this tool to save a lot of space. Another thing that we can do is we can generate gradients in Unreal. So rather than making a gradient like this in Photoshop and then importing it as a texture, that would be inefficient because then you save a rather large texture in Unreal, and it has to be a large texture, otherwise you would see a lot of compression on the gradient. Rather than doing that, and rather than making an image like this, for example, you would need to mask out the middle part of a texture, so you have a black and white texture here where the middle is white. Rather than doing that, you can generate these within Unreal. And besides saving a lot of memory that way, it will also give you better results, because then you can create a perfectly smooth gradient in Unreal. If you import this texture into Unreal, it will get compressed and it will harm the quality of the gradient. In Unreal, you have a number of functions called diamond gradient, linear gradient, radial gradient, and a smooth curve. But the gradient ones, these functions will generate these types of gradients. So this makes that. Here we have your radial gradient and a gradient like that. There's a couple of options you can use. For example, with the radial gradient, an S means it expects a constant 1, a V2 means it expects a constant 2. So for example, I can input this here and now I can move it over. So this is the offset and this is how big it is. So this is a much better way of doing things rather than importing it from Photoshop. You also have things called bands, generate band here. And you can see, it might be hard to see because you can't see where the cube ends. But now I pretty much have the same as I had in Photoshop. This, black and white. Black up and the top part and the bottom part is black, the center is white. I've now done the same thing in here, except that this is, let's say, 1 kilobyte or 2 kilobytes big.